Welcome to this explainer. You know, we rely on meters, kilograms, and seconds every single day without even giving them a second thought. But the real truth behind these foundational units, it's actually this wild story full of historical accidents, multi-million-dollar disasters, and some seriously mind-bending physics. Let's dive in, because you're going to look at a simple ruler totally differently after this.
All right, let's start with a classic childhood riddle. You've probably heard it a million times, right? What's heavier, a kilogram of feathers or a kilogram of iron? Everyone usually just rolls their eyes, laughs, and says they weigh exactly the same. Obviously, it's a trick question. But here's the crazy part. Almost nobody actually tests it. If you were to take highly sensitive calibrated scales into a normal room and put a kilogram of iron on one side and a kilogram of synthetic feathers on the other, yeah, they'd balance out perfectly. But things are not always as they appear on the surface.
So what's actually going on here? Well, it's the hidden force of Archimedes' buoyancy. Think about how water pushes a rubber duck to the surface. The air in the room is doing the exact same thing to that large, fluffy pile of feathers. It's actually pushing up on them, making them effectively float just a tiny bit. To counteract that lift and hit exactly 1 kilogram on the scale in open air, you literally have to add a little extra mass. Now, if you take that exact same scale and put it inside a vacuum chamber, completely stripping away the air and the buoyancy, the feathers will drop. They actually possess almost a full gram more mass than the iron. That trick question was playing us the whole time.
Section 1. A History of Messy Measurements. To understand how we could get something as seemingly simple as a kilogram wrong, we really have to look at how humanity stumbled into the bizarre, messy units of measurement we still use today. Spoiler alert, it wasn't exactly rigorous science. I mean, why are there 24 hours in a day? Just because ancient Egyptians counted the 12 finger joints on their hands using their thumbs. Why do ships and airplanes still measure speed in knots? Because sailors literally tossed a knotted rope into the ocean and counted how many knots slipped through their hands in 30 seconds. And horsepower? That was purely a marketing stunt. James Watt needed to sell his steam engines, so he wildly exaggerated their power compared to a horse. In reality, if a horse gets spooked and jumps, it can easily output anywhere from 15 to 100 horsepower in a sudden burst.
But here's the thing, these mismatched historical habits aren't just funny little pieces of trivia. They have caused massive multi-million-dollar life-or-death disasters. In 1983, an entire Air Canada flight lost all engine power midair just because the ground crew confused pounds with kilograms, basically giving the plane exactly half the fuel it needed. Or take 1998, when a team of international scientists completely lost the Mars Climate Orbiter. Why did a multi-million-dollar NASA satellite fail? Because one team programmed in European metric meters, and the other team used American feet. The whole thing burned up in the Martian atmosphere simply because humanity couldn't agree on a ruler.
Section 2. The Metric Revolution.
After centuries of total chaos, it became glaringly obvious that the world desperately needed a single, unified language of measurement. Enter the French Revolution. Their goal was to create something completely disconnected from random human body parts or arbitrary royal decrees. They wanted a universal standard based on the planet itself. So, they defined a meter as exactly 1/10,000,000th of the distance from the Earth's equator to the North Pole. They literally cast this length into a physical platinum bar, locked it in a vault in Paris, and declared it the ultimate measuring stick for the entire globe.
But old habits die hard, right? Standardizing the world was incredibly messy. Take Napoleon, for instance. History remembers him as this famously short man with a massive complex about his height. But guess what? He wasn't short at all. He was about 170 centimeters tall, which was totally average, maybe even slightly tall for his time. The myth only started because his death records listed his height in traditional French inches. Years later, British historians read that number and mistakenly translated it using English inches, which are slightly smaller. That one simple unit mix-up robbed the emperor of 12 centimeters of height in the history books forever.
Section 3. Redefining Time and Space.
Eventually, that grand metric plan ran into a massive problem. The physical universe changes. That metal bar in Paris, it's subtly degraded over time. Even worse, the Earth's rotation is actively slowing down. Did you know dinosaurs actually experienced 23-hour days? Because the Earth is so inconsistent, humanity realized we had to tie our units not to physical objects, but to the unchangeable cosmos. They needed something that never, ever changes its rhythm, and they found it in the cesium atom. Since 1967, 1 exact second is no longer just a fraction of the Earth's rotation. Instead, it is officially defined by exactly 9,192,631,770 vibrations of a cesium atom. It is the absolute, ultimate, unbreakable clock. And this extreme atomic precision,
It actually allowed us to see Einstein's theory of relativity play out in real life. Because these clocks are so breathtakingly precise, scientists in 1971 put them on commercial airplanes and flew them around the world. The clock that flew east, moving with the Earth's rotation, traveled faster relative to the Earth's center. It literally traveled into the past, losing 59 nanoseconds. Meanwhile, the clock that flew west, moved against the rotation, traveled slower relative to space, and leaped into the future, gaining 273 nanoseconds. It definitively proved that the faster you move, the slower time flows for you. No way around it.
Okay, here's a really fun one. You can actually bring this high-level physics right into your kitchen. You can measure the absolute speed of light using just your microwave and a chocolate bar. Seriously. If you take out the rotating plate, the microwave hits the chocolate with standing waves, melting it in two very specific spots. If you measure the distance between those melted spots, multiply it by 2 to get the wavelength, and then multiply that by your microwave's frequency, which is usually printed right on the back, boom, you've just calculated the speed of light. You absolutely got to try this later.
So, by knowing that absolute, unchanging speed of light, scientists realized they didn't need that degrading metal bar in France anymore. Today, the meter is officially defined as the exact distance light travels in a vacuum in 1/299,792,458 of a second. By tying the meter directly to light, we can precisely measure mind-boggling cosmic distances. We literally bounce lasers off reflectors left by the Apollo 11 astronauts to track the moon's exact distance from Earth to within 2 millimeters.
And that brings us to the final puzzle piece, the kilogram. In 2019, that physical metal cylinder in Paris was officially retired for good. The kilogram was redefined using Einstein's famous equation, E equals mc squared, which beautifully proves that mass and energy are perfectly interchangeable. By using this insanely complex device called a Kibble balance, we now define mass entirely through electrical energy. And get this, because energy and mass are the exact same thing, it means a fully charged iPhone actually contains more energy, and therefore physically weighs about 0.5 nanograms more than a dead one. Absolutely blew my mind when I learned that.
Section 4. Universal Alien Units.
Now, our modern metric units are incredibly precise, sure, but they are still inherently, well, human. A meter is roughly a stride, a kilogram is the weight of a water bottle we can hold in our hand, and a second is basically a heartbeat. If we ever make contact with a highly advanced alien species, they're not going to have our stride lengths or our heartbeats. We won't be able to communicate in meters or kilograms. We'd have to use Planck units. Discovered by Max Planck, these are derived entirely from the absolute fundamental constants of physics, like gravity and the speed of light. They are the absolute minimum measurable scales in existence, literally the fundamental pixels of our universe.
But honestly, there's a really good reason we don't use Planck units in our daily lives. While they are scientifically perfect and represent the true universal mathematical language of the cosmos, they are ridiculously inconvenient for us. Imagine walking into a local cafe and ordering your morning coffee by asking for 14 googles of Planck volume containing 23 million Planck masses, and then waiting 2 × 10 to the 40th power Planck times for it to brew. Yeah, the barista would absolutely not be amused. We stick to our human-scaled metrics because they simply make sense for our size.
Section 5. The weight of information.
So, we've conquered distance, time, and mass, but our modern world is completely dependent on something invisible: digital data. Can our foundational units actually measure abstract digital information? The answer is yes. Information requires electricity, electrons physically moving through circuits. If we measure the electrical current required purely for global Bitcoin mining in a single year, and we use Einstein's E equals mc squared to convert that energy back into pure mass, we get about 5.5 kilograms. To put that into perspective, the Tsar Bomba, the most devastating nuclear bomb humanity ever detonated, only converted about 2.5 kilograms of mass into pure energy. The digital network of Bitcoin heavily outweighs the physical energy mass of our greatest weapons. That is just staggering to think about.
See, information is highly physical. According to Landauer's principle in physics, the universe demands a toll for data. Because energy cannot be destroyed, only transformed, the act of irreversibly erasing a digital memory, switching a bit back to a zero, literally must release physical heat back into the real world. It's a tiny, tiny amount, about 3 × 10 to the negative 21 joules per bit, but it is a fundamental, unavoidable law of nature.
So I want to leave you with this final, provocative thought. Because every single deleted photo, every cleared browser history, and every scrapped text message releases a physical burst of heat into the universe, calculating the mathematical limit means that if you were to delete the entire internet all at once, it would instantly release enough heat to boil 2 teaspoons of water.
It just goes to show that absolutely everything in our universe, from the speed of light down to the quietest, most abstract secret sitting on your hard drive, carries a very real, measurable, physical weight.